So for this problem, we are going to find critical points and then extrema. So recall that critical points are where f prime is equal to 0 or undefined. Now this is a polynomial, so this is not going to have any undefined f prime values because polynomials are always like smooth curves. They're differentiable everywhere. So I'm going to go ahead and find the first derivative, and then I'm going to be able to just set it equal to 0. So the first derivative using the power rule is 4x cubed minus 12x squared. Set it equal to 0 to find your critical points. I can factor out a 4x squared, and I'm left with x minus 3. So I have critical points at x equals 0 and 3. All right, so I'm going to show you both the first and second derivative tests, okay? And you need to understand how to use both. You can't just say like, oh, I'll just use one or the other. You actually have to use both. So the first derivative test is figuring out where your maxes and mins occur based on the first derivative only. So remember, if you have a maximum, that's where your slope changes from positive to negative. And if you have a minimum, your slope changes from negative to positive. So we are going to use our critical points as candidates for maxes and mins. And they are just candidates. They are not necessarily either one. Okay, so the first derivative test, we are going to see where our f prime changes from positive to negative or negative to positive. So I'm going to graph f prime. You can use a sign chart if you'd like. Personally, I prefer to just graph if I can graph really quick. So I'm going to have zeros at 0 and 3 for f prime. And we are going to be starting in positive land because we have a positive leading coefficient. And it is going to bounce off of x equals 0 because that has an even multiplicity. Okay, and then where does this graph change from positive to negative? So there is no local maximum because f prime doesn't change from positive to negative. Like you'll notice that we change from negative to positive here at x equals 3, but we never change from above the x-axis to below the x-axis. And then we would have a minimum at x equals 3 because f prime changes from negative to positive. So I'm going through this quickly because you've seen a bunch of these examples already in chapter 3. So first derivative test is actually not new. You might be new to us calling it the first derivative test, but you have already done these types of problems where you're figuring out where you have maxes and mins based on the first derivative only. What's new to you is the second derivative test. Now, the second derivative test is nice because it's a different way of looking at it. And sometimes the second derivative test is actually nicer to use than the first derivative test. And sometimes it's not helpful at all. So for example, here, what I'm going to do is I'm going to find the second derivative, and it is 12x squared minus 24x. And then what you do is you test each critical point. So if I plug in 0, I get 0. And what that tells me is that there is no max or min. Again, only because I have a, actually, that's not true. I just said there's no max or min, but that's because I know there's no max or min. It's actually inconclusive. So the second derivative test is inconclusive because I got its value of 0. Now, why does that mean it's inconclusive? If you have a function that is concave up and you have a slope of 0, so slope of 0 and f double prime is positive, that means you have a minimum. If your slope is 0 and f double prime is less than 0, so slope is 0, but my function is concave down, that gives me a maximum. So that's the second derivative test, is using f prime equals 0 and f double prime is either greater than 0 or less than 0. But if it's equal to 0, this is a special case where the second derivative test is inconclusive. But if I find the second derivative at 3, and what you'll find is that I actually don't care about what the number is. All I care about is this number going to be greater than 0 or less than 0? So 12 times 3 squared is 12 times 9 minus 24 times 3. So 12 times 9 is 108. 24 times 3 is 72. 108 minus 72, I don't actually care what it is. All I know is that it's greater than 0. So what this tells me is at x equals 3, f has a local, and then just think, okay, my second derivative is greater than 0. That means my function is concave up. So we would say at x equals 3, f has a local minimum because, and for the second derivative test, you have to use both parts, because f prime is equal to 0. Okay, and f double prime of 3 is greater than 0. And what's nice is you don't have to use the word like change from blank to blank. You're just saying, okay, the slope is equal to 0 and the function is concave up. That's essentially what you're saying, although you're writing this. Then that means I have a minimum. Okay, so it's another way of proving that you have a minimum besides using the first derivative test. And that's to show that a function is concave up or concave down. In addition to that the slope is 0, because just because it's concave up, like this point is concave up, this point's concave up, this point's concave up, none of those are minimums. The reason that this is a minimum is because the function is concave up and the slope is equal to 0. So that's the second derivative test. Okay. And I want to find the absolute. So it says find the extrema. So what that means is that I actually want to find the max value and the minimum value. So there is no maximum here. What this tells me, I mean, if you think about it, x to the fourth, both sides are going to go up. So there is no, this is going to look something like this, where there is no local maximum. Okay, there's no local maximum. I figured that out using the first derivative test. So there is no maximum, but there is an absolute minimum value. So let's figure out what the absolute minimum value is. And the way you would do that is you would plug in 3 to the function, right? Because we know that the local maximum is going to be at x equals 3. I have no other candidates for local minimums. So, and I know that both sides of this go up. So I know there must be an absolute minimum. So let's find the absolute minimum. We plug in 3, we get 81 minus 4 times 27 plus 7, which is 81 minus, 80 plus 28 is 108 plus 7. That's 81 minus 101, which is, that's going to be negative 20. So that is my absolute minimum value. So when you see the word value, that means the y coordinate, not the x coordinate. So the absolute minimum value is negative 20, and there is no absolute max value. Okay, so I had to combine a lot of things for this. I had to use a bunch of calculus. I also had to know how to graph basic polynomials. I need to know that x to the fourth means my both ends are going to go up, right? Things like that. So I know there's a lot in this, but just make sure you can go back and rewatch the video. Make sure you understand every part.